This podcast was produced by OAR FM Dunedin with support from New Zealand On Air.
The Science Notes podcast on OAR FM Dunedin, brought to you by the Division of Sciences at the University of Otago. I'm Dave McMorrin. Over the next half hour, I'll be chatting with a graduate science student about their research, their passion for science, and the things that fuel their creativity. Well, hello there, and welcome again to Science Notes. My name's Dave McMorrin, and this time our guest is Namrata Chand. Hi, Nam.
Kia ora, Dave.
Thanks for coming along on a rather damp Dunedin day. Nam is finished, really, now, except for all the shouting at the end, a PhD in marine science at Otago University. So congratulations on getting through the writing and the submitting and all of that. Yeah. It's not always the funnest part of the process.
No.
But in fact, as prep, Nam sent me her entire thesis, and it looked really nice from what I could see.
Oh, thank you.
So how was it then that you ended up in Dunedin doing a PhD?
So I am from Fiji, and I was lucky enough to come to Otago to do a degree on a scholarship for the program Aquaculture and Fisheries. And it was quite a shock to the system temperature-wise for any Pacific Islander.
You don't come here for the weather if you live in Fiji, no.
And sometimes when you think of it, not even for the ocean, leaving behind the warmth and the corals. And I had a really good experience with my degree at Otago. And it left a very positive impact on me. And after my degree, I did go back to Fiji for a few years to work and do a master's. But I always knew that if there was one place I'd go back and do my PhD, it would be at Otago.
Right.
And so I did come back and definitely expanded my horizon into diving in Otago Harbour, which I hadn't done previously in New Zealand at all. Yeah.
So this is proper scuba diving?
Absolutely. Yeah.
So so you hadn't done scuba diving in Fiji?
I had.
Oh, right.
But the temperature was rather very different here, and the thickness of your wetsuit was so different. So,
I mean, I suppose that's the thing. Until you do it, you don't really think that it's harder to move because it's thicker and it's heavier. And
yeah, you feel like a penguin without the ability to not move much. But I wouldn't change it. It definitely was a great experience in hindsight.
Yeah. What did you do? Did you do your master's in?
I did my master's. It was in environmental science at the University of the South Pacific. And what I did there is I used remote sensing, so satellite images, to map seagrass beds in a very large lagoon.
Right.
And the idea was to produce visual data that could be used easily for decision making. And there's a lot of interest at this stage, wasn't then, in the idea of seagrass as a blue carbon storage. With climate change on the move, we're trying to mitigate. And for the Pacific, it's such a big thing about ecosystems that naturally store carbon, and seagrass was one of them.
So in New Zealand, everyone wants to plant trees, and your farm's sort of getting rid of the cows and putting trees instead. In Fiji, you've got a limited amount of space to do that, but you can grow plants in the ocean.
Yes, and in Fiji we have more species of seagrass than New Zealand. New Zealand has one.
Right.
And so, yeah.
I'm sure it's a good one.
Yeah, it is. It is great. And I suppose just showing people the visual representation so they know what we have was quite big for me. And so in a lot of ways, I did my master's in what they call macrophytes, or like plants that grow under the ocean. And I think that was the link to my PhD. Yeah.
So you came back down here then?
Yeah.
About 4 years ago, I suppose?
Yeah.
So 2020?
Yes.
Oh, good.
Not the best time to start.
And here you've been studying seaweed.
Yes.
And one particular type of seaweed.
Correct. It's one I say that looks like red crispy bacon. And I often get asked, does it taste like crispy bacon? If you ever eat it, please let me know. I'm yet to taste it. And it's a seaweed that's endemic to New Zealand, so only found in New Zealand, and it's called Adamsiella. And the unique thing about this seaweed is it grows in mud and sand, or what we call soft sediment, and not many seaweeds, if any, in the whole world can do that.
Right. So normal seaweed,
Yep.
if I can say that.
Yes.
Where do they grow by comparison?
Most of them are known to grow on rocks. So imagine going to the beach here in Dunedin and being on a rocky shore. And when the tide goes out, you'll see all this seaweed attached to a rock. So seaweeds don't have roots, but they have something called holdfast. And it's similar, and it holds on to a hard structure.
Right.
And so most seaweeds need rocks to attach themselves onto and then grow from there. And the second way most seaweeds grow, or rather one in particular, is they'll be free floating or drifting on water. But the unique thing about Adamsiella, it has a tiny holdfast that's almost like a disc, and it just anchors itself to mud and sand. And in turn, it's able to provide home for lots of other seaweeds, and not only seaweeds, for fish, scallops, kinna, lots of other animals in the process. So we call this habitat formation.
So it's kind of like the big trees in a forest.
Correct.
That all the other things live underneath and in and around.
Yes.
But in a particular type of environment in the ocean.
Yeah.
Right.
Yeah. And the unique thing is that it also is a long-lived seaweed. So it doesn't just bloom in January and die off in December. It stays around for many, many years.
So is that a thing? I mean, as a complete ignorant person about seaweed,
yeah.
Is it like a normal plant in that you see it at certain times of the year and then other times it dies away?
Some seaweeds in particular, they are very opportunistic, or they have short lifespans. So, for example, some of them bloom or come to life when conditions are good, like right now in spring, when nutrient in the water increases, light increases, they'll come to life. And then when nutrients start decreasing, competition increases, light goes, they'll die off.
Right.
And some of them are annuals, which means they'll live up to a year. But Adamsiella is what we call a perennial, a long-lived one. And so the biggest advantage of that is it provides stability in terms of the home it creates.
Yep. It's easier for you to study it too, I suppose.
Yes, to go back to it.
Because it's still there.
That's right, yeah.
So then whereabouts is your place of study?
I focused on Otago Harbour. So it's a much loved body of water seen from many places in Dunedin. And the Otago Harbour stretches right from near the city towards Tairoa Head. And I studied Adamsiella beds, or my sites were right from close to the city all the way to Tairoa Head. So I monitored 12 places.
Right. How long is the hub?
I think 22 kilometers.
Yeah, it's quite long, isn't it?
Yeah. So it took me a few days in a week, or to spread out and take a team and go diving and collect. Yeah.
And I would imagine, given that, like you say, one end of it is near the city and the other end is out at the ocean, and quite a long way from most civilization.
Yeah.
There's quite a difference in the environment in which the seaweed is growing.
Yep, absolutely. So part of my first question that I asked was, how is the environment looking in the harbour? Because in order to understand what lives there, we had to look at the conditions in the water. So I put something called light loggers under the water because light is so important for photosynthesis and growing. And so I monitored light levels close to the city, near Portobello, which is like the midway point of the harbour, and then out towards Wellers Rock or closer to Tairoa Head. And I also monitored temperature and nutrients in the water. And
I mean, you knew it was cold, but you want to know how cold.
Yes, I didn't know it could hit 6 degrees in winter cold. Yeah. And so that formed the foundation, or understanding what we call the environmental or abiotic condition formed the foundation for me to understand the differences in how much of the seaweed was in the harbour. Because what I found is that the biomass of Adamsiella closer to the city or in the inner harbour was not the same as the outer one for many reasons. Yeah.
Right. So that mostly is to do with the nutrients or lack thereof, or
it had nutrients dictated some of the patterns, and we saw differences in light conditions. Like the outer harbour was receiving more light compared to the inner harbour or
That's
the mid harbour. Yeah, and I also think it has to do with like angle of the sun, etc. Like you clearly ask, like if you have ever gone sledding or know people who live, say, in Ravensbourne.
Oh, yes. Or on the cold side of North East Valley, which is where I live.
Yeah. And the hours of sunshine you get is so different compared to someone who lives, say, towards Harrington Point. Yeah. So imagine if I were to explain it that way. Yeah.
So the difference in light is more to do with the time of the year and the fact that there's quite steep hills around the harbour.
That's right.
Yeah.
Yeah. And I monitored light for a year because we're in the temperate ocean, which is dictated a lot by seasons. And so there was very clear seasonal patterns in light and temperature, and that reflected on the seaweed as well.
So what then? So you put out these little sensors to measure certain things, but you also obviously go diving. So are you going down just to look at them, or are you taking samples, or? So
every season, my study was divided into summer, autumn, winter, and spring. Winter dives are obviously the hardest, and trying to convince people to come dive with me. And I would say on this note that it absolutely takes a village to raise a child, in a sense of the amount of people who helped me in my research. And we would go out diving every month, and much like how you go grocery shopping and take shopping bags, we took something called catch bags underwater. So we had 4 sites in the inner harbour, 4 in the middle, and 4 in the outer harbour that we'd monitor every season, and I had GPS points for this. We'll go back to the same locations, put down a tape, a 30-meter tape, and go scuba diving. And with a quadrat, we'll harvest everything at 5 random places.
Right.
And the reason for that was we are diving in mud. So as soon as the biggest factor was it's very dark. And you can't use research methods like put a camera over it and just monitor, because these seaweeds are covered in lots and lots of sediment or mud. And I wanted to know what other seaweeds are living within the community.
Yeah.
So we harvested them into bags and brought them out to the lab. And I became what I call a seaweed sorter, where I went from not knowing not knowing how to ID one species to now I have a wealth of knowledge about how to identify seaweed species. And we ended up finding 47 other seaweeds that live within Adamsiella, which was huge.
And now these are these important life skills you learn at university. Now
Yes.
you can, by sight alone, separate them all out? Or-
Yes. Yes, so I separated most of them by sight.
Yeah.
And we did do genetic work on the Adamsiella.
Yep.
I started off thinking it was a species called Adamsiella chauvini, love Latin names, but the genetic analysis showed it's something called Adamsiella angustifolia. And this is where, even though genetics is a very expensive tool to deploy, some species can look so similar, and it was powerful to be able to get the help from NIWA in supporting my research for the genetic analysis. Yeah. But most of them I identified by sight and also with the help of someone called Wendy Nelson, who pioneered a lot of the seaweed identification for New Zealand.
Right.
Yeah.
The fact that it wasn't the exact species that you thought, was that a big deal? Was the other one known to live in New Zealand already, but not in the harbour, or?
Yeah, so there's 4 species of Adamsiella, and 2 of them are distributed widely around the North and South Island of New Zealand. Otago Harbour, all previous research done from the harbour had reported Adamsiella chauvini.
Right.
However, none of it prior to me have done genetic testing on it. And it's really hard to separate the two. So I'd said it does look like crispy bacon. And one of the things separating them is one of them would have a rolled tip, almost like a rolled tongue. And it's
Right.
so hard to see with your naked eye. And their cellular structure is different.
Yeah.
And Adamsiella angustifolia is known to be more of a coastal species. So when I say coastal, it can live in more exposed,
Right.
wave-exposed sites. So we did not expect it to be in the harbour. And the question is also there whether this was the one all along or whether Chauvinia is still in the harbour. We don't know. Could make future research projects for investigating. Yeah.
Although it seems, do you know that the previous work, was it sampling in the same places as where you were going?
Yeah,
Right.
some of them, yeah.
Yeah, so then
Yeah.
it seems
Yeah.
less likely, isn't it?
That's right.
It's just that they were mistaken all
Yeah.
along. So,
Yeah.
so then it's a unique type of seaweed in that of where it grows.
Yep.
Is there any? So was that the main reason why why the research project focused on that? Was just to try and understand more about this type of seaweed and how it does what it does?
Yeah, I think we went from a scope of absolutely wanting to find out more, because before me there was only one previous student who's ever done a PhD on it, and that's more than 15 years ago. And in the harbour, if you're up hiking on a hill and if you look down in Otago Harbour, you'll see these dark patches. And it is Adamsiella making what we call beds, like huge amounts of seaweed is called a seaweed bed. And so we know it exists in quite large numbers. And there was not much known about it, yet there were reports that came out saying that it grows all around New Zealand, places like Stewart Island, Fiordland, Marlborough Sounds, and it's important for, like, you often see scallop fish or like scallops in there, lots of fish, horse mussels. So there was an idea that it's quite important for supporting fisheries or organisms of fisheries importance in New Zealand. But so far there was nothing done on quantifying its habit, like how much there is, how it behaves seasonally. And so the previous person who did her PhD set a really good foundation for me to come through. And I suppose I really appreciate that about the nature of research and science, that you are contributing to a body of knowledge and then someone else in the future can come and pick it up and add on to it.
Yep. And the understanding becomes more and more as time goes on.
Yeah.
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 Cool. So you've submitted and you're waiting.
Yes, for examination.
calmly and patiently for the final parts, the examination process and the interview. What then for you after that?
That's a great question. I did realize that I suppose, like for anyone thinking of doing, whether it be a master's or a PhD, I think the biggest product that comes out of it, yes, it is your thesis, but it's you. Like for me, it was a huge journey of realizing the aspects I enjoyed, the aspects I didn't enjoy.
Yeah.
I really enjoyed the science communication aspect, which was by going to conferences, presenting my research, going on podcasts, talking more about my research. I enjoyed teaching students, whether it be in labs or helping out and giving a lecture. And I also did enjoy research. So I would still like to be in the field of research, possibly through a postdoc.
Yeah.
Yeah. So I'm trying to align myself to that.
And would that be something? Would you be wanting to stay in New Zealand, or are you looking to?
Yes, I would be wanting to stay in New Zealand. I really enjoyed being at Otago, research here. And I come from Fiji, and one of the things that's been really big for me is I want to go into bridging or doing research more with Pacific communities and the ocean connection.
Yeah.
Yeah, so that's the space I'm thinking of exploring next.
Excellent. Well, thank you for coming in and talking to us about what you've been up to. And all the best for whatever's next, and for the rest of the PhD process, of course.
Awesome. Naka, Dave, thank you so much.
Thank you. And thank you all out there for listening. You've been listening to the Science Notes podcast, brought to you by the Division of Sciences at the University of Otago. To listen again, or to find other episodes in this series, go to Otago Access Radio's website, oar.org.nz, or to your favourite podcast platform.
This podcast was produced by OAR FM Dunedin with support from New Zealand On Air.